Okay, so I wanted to show you two examples before you did the homework. There are a couple examples or a couple problems on the homework that just aren't exactly like what we've seen in the notes so far, so I want to go over a couple of these on this separate worksheet here. So we're asked to find the holes, vertical asymptotes, x-intercepts, which are zeros, and horizontal asymptote of each. Then sketch the graph. All right, so what we should do first is factor anything we can. So I can factor out a negative 2x from the top. And then I'm left with x plus 3. Okay, and then I've got factor the denominator, and that's x minus 1 times x plus 3. And right away you might notice that we're going to have some canceling going on. So x plus 3 gets canceled, and then we're left with negative 2x over x minus 1. So remember, this stuff that got canceled, that's going to create the hole. So x plus 3 set equal to 0. Well, subtract 3, x equals negative 3. There's going to be a hole at negative 3. Okay? So the vertical asymptote, remember the vertical asymptote is when the denominator, in this case that's x minus 1, is set equal to 0. Add the 1 over, and x equals 1 is the vertical asymptote. All right, so then the horizontal asymptote, remember there are three different situations depending on the powers of the numerator and the denominator. So since they're both 1, they're equal, that means we look at the leading coefficients. So this 2 and then the 1 in front of the x. And that's what our horizontal asymptote is going to equal. So y, because it's horizontal, is equal to negative 2 over 1. And then that's going to equal negative 2, which is, that's an equation, y equals negative 2. Then the zeros are when we set the numerator, that's the negative 2x, equal to 0. And divide both sides by negative 2, and x is equal to 0. So 0 is our 0. All right. So now we're going to sketch the graph. So let's plot some of the stuff we know. So the 0 is at 0. So that's right there. We have a vertical asymptote at x equals 1. A horizontal asymptote at y equals negative 2. Okay. And the hole is at x equals negative 3. So that just means when we graph at negative 3, we'll just have to put that circle to represent an empty spot. Now we'll make a table, and we'll graph a few points. We'll graph a few points to the left and right of the vertical asymptote here. Okay, so we already have 0, but other than that, going to the left, we can graph negative 1, negative 2, and we should probably graph negative 3 since that's an important thing is happening at negative 3 because that's where the hole is. So start with negative 3, negative 2, negative 1. And then going to the right of the vertical asymptote, that's going to be 2, 3, 4. I think that'd be good. So let's see what we get. So when we plug in negative 3, we're looking at our simplified version up here. Now I did a lot of writing up there, so I'm going to rewrite that. Negative 2x over x minus 1. Write that over there. So I don't have to keep scrolling up and down. Okay, So now it's about simplifying by plugging in these x values into this function. So plug in negative 3, we get 6 over 4, or no, sorry, negative 4, which is negative 1.5. When we plug in, and now that's actually where the hole is. So let's keep making note of that. Okay. So when we graph that spot, we're actually going to graph it as a hole. All right, so plug in negative 2, you get 4 over, that would be negative 3. So this is actually equal to 1.3, or negative 1.3 repeating. So we'll just say about negative 1.3. Plug in negative 1, that's going to be 2 over negative 2. So that's equal to negative 1. Okay, plug in 2, that's going to be negative 4 on top, and 1 on the bottom, so that's just negative 4. Plug in 3 into the negative 2, that's negative 6, divided by 3 minus 1 is 2. Negative 6 divided by 2 is negative 3. And plug in negative 4, that's negative 8 over 3. And negative 8/3 is negative 2 point, it's approximately, because this is going to be another one. I think negative 2.7 approximately, right? Goes in twice. 2 left over, yeah, okay. All right, so let's graph these. So the first one is negative 3, negative 1.5, but there's a hole there. So we go negative 3, negative 1.5, and we put an open circle there, because that's a hole. Okay, then negative 2, negative 1.3, about right there. Negative 1, that's an easy one. And then that's it for the left side of the vertical asymptote. So I'll draw my graph, stop at the hole, start up again, it'll keep going after the hole. Put my arrows in. Okay, so now for the right side of the vertical asymptote, 2, negative 4, right here, 3, negative 3, right there, and 4, negative 2.7, right about there. And you can kind of get an idea of what that's going to look like. There's no holes on this side. There we go. So it looks kind of like what we've seen before, except we've got this hole where negative 3 is usually. Okay? All right, let's take a look at another one. So this is going to be on the other side. Okay, same thing. First step is to factor top and factor bottom. So on the top, I can factor out x squared. Then I'm left with x minus 1. On the bottom, I can factor out a negative 3x. And then I'm left with what? X squared minus 4. And so we can keep factoring a little further on the bottom. Negative 3x, x plus 2, x minus 2. Alright, so this is kind of a crazy looking one so far. Now, when it comes to canceling, there's not a ton that we can cancel actually. We can cancel out an x. So x, and we can cancel out 1x here, so I'm just going to cross off the 2. So it looks like there's just 1x up on top. So the x is what we canceled, okay? So that is what is, we set equal to 0 in the hole. So we have a hole at just x equals 0. We don't have to solve it because that's it. Okay, so the hole is taken care of. Now for the vertical asymptote, remember with the vertical asymptote we set the denominator equal to 0. Let's rewrite this nicely without all that x's or crossing off. Doing a little work here. Hopefully you can still hear me. So then the bottom is negative 3, x plus 2, x minus 2. Okay, so we set this denominator equal to 0. The x plus 2 and the x minus 2. The negative 3 really doesn't affect it because there's no x with it. So what two values are going to create zeros here in the denominator? Well, one would be when x is equal to -2, and another one would be x equals +2. So we're actually going to have two vertical asymptotes. We saw an example like that yesterday. Okay, now let's take a look at horizontal asymptotes. Okay, so let's look at the very original problem, not the factored one that we did, the original one, when we see that they have the exact same leading coefficient. I'm sorry, I said that wrong. The exact same power on the leading term. So since we do that, then we look at the 1 and the -3, and that's going to be our horizontal asymptote. So y is equal to 1 over -3, or that's just y equals -1/3. I don't know if you want to rewrite that so it looks a little nicer. Okay? So that's going to be our weird, that's a weird horizontal asymptote. It's just down a third, but it works. And then the zeros. Looks like we're going to have a couple on this one. So, go purple. Okay, set the numerator equal to 0. So x times x minus 1 equal to 0. Alright, so again, we're going to get two values. So for x and x minus 1. So from the x, if you set that equal to 0, you just get x equals 0. You set x minus 1, so this one gives us 0. You set x minus 1 equal to 0, you get 1. So we have two zeros. We have a horizontal asymptote at -1/3, y equals -1/3. We have two vertical asymptotes. And we have a hole at x equals 0. So, alright. Let's be careful here. So first, I like to graph my zeros first. So x is at 0 and x is at 1. So the 1 is fine. I can just put that right there. But be careful when you graph the 0 at 0, because we also have a hole at 0. So at 0, 0, we're going to put a hole there. Okay, so it looks kind of weird. Those points are really close together right now. Okay, now let's draw on those asymptotes. So the vertical ones, -2, +2. Okay. And horizontal asymptote at -1/3. So I'm going to go down about where I think 1/3 is. Okay. All right. So let's take a look at this. All right. So now it has to do with graphing again, or plotting those points. So first, let's pick some good points to the left and right of these vertical asymptotes. So to the left of that x equals -2 vertical asymptote, let's go with the x values of -3 and -4. So I'll start off with the smallest, so -4, -3. 2 should be enough there. Let's plot at -1. I see I can get an x value in there. And then on the right of 2, we can go 3 and 4. My guess is that this is going to be symmetrical, but let's just verify it. We're going to use the simplified version to graph. So that's way over here, the simplified version. Let me rewrite that down here so I don't have to keep scrolling up and down. Alright, so lots of stuff going on there. Okay. So, plugging in -4, we would get -4 times -5, so that would be 20 on top, divided by 2 and -6, so that would be -12 times -3 is 36. Alright, so that's going to be some decimal value. It's going to be over a half. Okay, let's see here. Alright, I'm embarrassed to admit I grabbed a calculator. But anyway, so this is about equal to 0.56. because it repeats. Okay, so for -3, you plug it in, -3 times -4, that'd be 12 on top. On the bottom, we'd have -3 times -1, that's +3 times -5 would be -15. So 12 divided by -15. Okay, hold on. Okay, maybe some of you caught this mistake, but that top one should have been a -36. So then this would have been a -0.56 repeating. That makes a little more sense. Okay, over here then we get -0.8. So some pretty small numbers. All right, if we plug in -1, we're going to get -1 times -2 is going to be a +2 on top. And on the bottom, we're going to have -3 times 1 times another -3. That'd be 9. So that equals 0.2 repeating, or just about 0.2. All right, on the other side, let's see, 3 times 2, that's 6. And on the bottom, that's -15 times 1, that's -15. That's, did I already do that right? -3 times 5 is -15 times 1. Okay, yep, on the top, 3 times 2. Okay, all right. So then that's equal to -0.4. And then on the top, we'll have 12 on this next one, and then -18. So that's going to be -36. And that's equal to -0.3 repeating. Okay. All right, so some different looking ones here. All right, so now for graphing. Okay, so -4, we're at -0.56 repeating. So that's below -1/3, so about right there. And then we're at -0.8, so we're a little farther away from that horizontal asymptote. So it doesn't give us a ton of information, but at least it tells us where the curve is, that it's on this side of the asymptotes, in the bottom left corner. Okay, at -1, we're at 0.2, so just a touch above the x-axis. And then this is going to be a curve like so. Stop at the hole and then start back up. So something crazy like that. Okay, and then on the other side, we've got 3 -0.4. So that's a little bit below the -1/3 mark, and then number 4 is like right on the, basically. Okay, and then we'll have a really close curve like so. Okay, so hopefully that can be helpful for a couple homework problems. I think on the worksheet I said 7, 10, and maybe 12. So right now you should work on the homework, the 5-4 homework, then any chapter 5 homework that you didn't get done, and then on page 357 there's a review over 5-1 through 5-5. We haven't gotten to 5-5 yet, but that's if you're all caught up with those things, then you can work on that page 357. All right, see you guys Monday.